Welcome, my name is Miguel Blom, and in this tutorial I'll be giving a quick rundown of the multistriding experimental framework which accompanies the paper Multistrided Access Patterns to Boost Hardware Prefetching that I've co-authored with Christian Rietveld and Rob van Nieuwpoort. So after cloning the Git repository, we should make sure that all of the prerequisites are met. Next, we will configure our machines by first specifying a name, an execution manager, which is either direct or we can make use of a Slurm environment. We set the remote address used in SAP to upload and download the whole project. We configure whether we want to use MSR, or we can use MSR in this on this machine, meaning that we are able to disable and enable hardware prefetching. Then we should also specify whether we should make use of sudo to run commands, which comes in use when measuring with perf. We set the paths to the local installations, and over here we see some machine specific configurations for experiments such as the compute optimized experiment. Most importantly here, to extend our framework is to add experiments, which will call generators using a configuration where the user also specifies its own generator, which are Python codes, Python scripts that generate assembly through parameterization given a striding configuration and dimensions of the data. So assuming we want to make use of a remote machine, we will first call this command to upload the directory to the Blom machine, where we upload to the directory that's been specified in the configuration file. I've already done this, so we go over here. We can either test our framework by calling the program again with the T mode and specifying the name of the machine that we are currently on, followed by a comma-separated list of experiments. We can also run the experiments, as we'll do over here. So what we see over here is MSR is turning the hardware prefetcher on or off. We skip experiments that are already existing, and we generate experiments for which the results are not present yet, and then run them after. For machines that do not let us plot the results into graphs, because we are missing pandas or matplotlib, we will download the resources for this by specifying the D mode and specifying the machine name again, and we'll use its address to download its whole directory, where all resources are then collected under resources followed by the machine name, where also the results are subdivided into directories depending on the experiment and kernel run. Say that we want to plot the results of the DOS6 machine, where we want to plot the compute experiment. We run the following command and let the program run. After a couple of seconds, a results folder should pop up with the plot results that are also found in our paper, together with aggregated CSV files. Lastly, we can clean our project and also dispose of all of the resources and result files by specifying the min-a option, but simply cleaning or made files, such as in the stream benchmark that we use, are done by solely using the C option. So that's all I'm able to summarize within 5 minutes, and I hope to see you again. Bye.